Hi, so I'm Jessie, and at E3, so we're an environmental consulting company, and as well as doing a lot of the GIS stuff, I wear a few different hats, and my colleague and I also do the identification of macro-invertebrates for the freshwater and the marine setting. And once we've done the ID, there's a bit of maths that does come after this, and I've just created a way to automate that. So I wanted to share this with you because this is one of these odd projects for me that just worked. Usually my coding projects don't do that. So I made the first chunk and it worked, and then I made the second chunk and it worked. If you haven't made a Shiny app, I feel like it's a very good advertisement. They just work. But R, or Shiny, is an extension of R, which is statistical programming language, and the Shiny app is a web-based application that you can kind of push all your data out to and make it quite interactive and do some cool stuff. So, macro-invertebrates, what are they? I'd included some pictures for the cute factor with a wee video also for the cute factor, but I feel like I've missed the mark after we've seen the husky dogs. But this is an example of freshwater inverts. So we've got a mayfly in this first slide here, Dilithidium, and it's really small, but there's a segmented worm in that second one. And this is a hydrobiosis. And have I do the video? There's the video. Yay! So basically, a guy called John Stark in New Zealand, he's been doing this since the 80s, and he sort of created this indices kind of not a network, but this indices framework and assigning values to inverts to kind of help quantify water quality and the diversity and richness of habitats. And this will feed into like a wider part of an ecological assessment for us. So, for example, Dilithidium's got a MCI score of 8, hydrobiosis maybe 5. Basically, the higher your overall MCI score, the better chance you have of some good water quality. In contrast, there is the segmented worm I think it's got a value of 1. I don't have a photo of it, but there's these cute little things. They're like the size of a jelly bean, or the shape of a jelly bean, but the size of a chia seed. They're called an ostracoda. And they've got like cute wee legs. They're very cool. They've got indices of I think about 3, but they're also like one of the few things that can survive in sewage treatment ponds. So if you have lots of worms and lots of ostracoda, you've probably got some pretty poor water quality, and I wouldn't recommend drinking it. So once we've got these indices, when we went to do the enumerations, it was all done in Excel. It was quite a manual process. You had to grab your species and find your MCI score and then enter in how many inverts you had in each sample. And so you were changing the number of rows and had to fiddle with the formulas, and it was all a bit time consuming. It only did some metrics, and then there was a second table that you had to copy everything into to do that other calculation for the Shannon Diversity Index and the evenness. And I didn't like it, and it took a long time. There's probably a lot nicer way of doing this in Excel, but Excel and my brain are not super good friends, so I made a Shiny app. So basically this involved a drop-down tab to CSV. It sits on GitHub. This is based on Stark 98 and Winterbourne 2000, the values associated with the freshwater inverts. And so that drop-down tab, you can choose the inverts that you have in your sample, and it populates into the table, and it automatically populates the MCI value for the hard bottom and the soft bottom streams. And so you can do those, and then you can just add in as many samples as you need, and you can just add in all your values, and then you can click the calculate button, and voila! So many calculations, it doesn't even fit on the screen. And then once you do that, you can export it into Excel and then into the report, and these are all the things that it calculates. And this is how you automate macro-invertebrate enumerations in R. Thank you.